Now we're going to look at the opposite angles and parallelograms. So I have a parallelogram here, ABCD, and all we know is that the opposite sides are parallel. And I can say AB is parallel to CD, BC is parallel to AD, because that is the definition of a parallelogram. I can also say that angle A and B, those are same side interior angles. So when I add them, I should get 180 because the lines are parallel. Same thing for angles C and B. The reason I did A and B and C is that means that A is supplementary to B and C is supplementary to B, which means that both A and C must be congruent by the congruent supplements theorem. I can do the same thing centered around A now. A and D are same side interior angles, and so they're supplementary, and A and B are supplementary. So that says same side interior angle theorem, which means that angle D is congruent to angle B by the congruent supplements theorem. So I've just shown that the opposite angles of a parallelogram will always be congruent. So if a quadrilateral is a parallelogram, then opposite angles are congruent. Now let's do the converse. If opposite angles are congruent, then a quadrilateral is a parallelogram. So I have a quadrilateral here with opposite angles that are congruent. Do these opposite sides have to be parallel? Well, we're going to set up an equation using the sum of angles for a quadrilateral, and we're going to develop a relationship between these consecutive angles. So x plus y plus x plus y equals 360, because there are 360 degrees in a quadrilateral. So I can say 2x plus 2y equals 360. I can actually divide everything by 2. And that ends up with x plus y is 180. Well, that means that x and y are supplementary. And so that means the converse is true, because if these angles are supplementary, that means that BC and AD must be parallel, because these are same side interior angles. Same thing with AB and CD, because I have y and x here. They're supplementary, so that makes these segments parallel. So if opposite angles are congruent on a quadrilateral, that is enough to know that it is a parallelogram. So now we're going to see, is this one a parallelogram? I'm going to use the sum of angles, must be 360 for a quadrilateral, combine my like terms, and solving for x, I get x is 49. Now I'm going to put 49 back in for the other angles. I get 64 degrees for angle A, 114 for D. So far angle B and angle D are congruent. But now I get 68 degrees for angle C. ABCD is not a parallelogram since the opposite angles are not all congruent. I would have to have the same answer for angle A as angle C. So for further reflection, why do the opposite angles of a quadrilateral have to be congruent if the opposite sides are parallel?